Hello and welcome everyone to my YouTube channel Imavate Academy. My name is Sunando Devnath. I was discussing the chapter hydrogen from class 9th portion of chemistry of ICSE. This is the fourth lecture for this chapter. In this lecture I will be starting with a very important topic, which is laboratory preparation of hydrogen. This is one of the most important topics in this chapter. You have a lot of questions from this topic. Now, the very first thing we have to know is the reaction, because we are preparing what? Hydrogen. So we will prepare hydrogen in the laboratory by reacting two substances. Now, what are the reactants and what is the reaction? Write down the reactants in this is granulated zinc. Now you should not write only zinc, it is granulated zinc. I'll tell you why. Granulated zinc. And what will I take? I'll take dilute hydrochloric acid or I can also take dilute sulfuric acid, either of the two. Either you take sulfuric acid or you take hydrochloric acid. These are the reactants. Now what about the reaction? So reaction, you have taken granulated zinc, means zinc in the form of granules. Now when zinc is in the form of granules, we say granulated zinc. It is not pure zinc. It is actually zinc which has impurities of copper present with zinc. You have to keep this in your mind. When copper is present with zinc, we call it granulated zinc. This is an impure form of zinc. Now we don't want pure zinc in the experiment. We want this impurity of copper to be present with the zinc, because the copper, catalyzes the reaction. It increases the speed of the reaction. That's why we use granulated zinc and not pure zinc. Okay, this is something which comes in your exam also. We will write about this later. Okay, so reaction क्या हो जाएगा? Zinc हमने लिया Zn plus hydrochloric acid HCl dilute. Now you see it's very simple displacement reaction. Zinc and this chloride ion will combine together, ZnCl2 zinc chloride, plus this H hydrogen from the HCl. This forms hydrogen. This separates out and it forms the hydrogen gas. Now it is time to balance the equation. Just a 2 is required and the equation is balanced. So I told you we can also use dilute sulfuric acid instead of dilute hydrochloric acid. So let us write the reaction for H2SO4. It is also very similar. Zn and SO4 will combine. So ZnSO4 zinc sulfate, and again this hydrogen will be separated out. So it is liberated as a gas, and this equation is already balanced. So you see, it is very easy reaction. एग्जाम में आएगा, अब तुम लोग आराम से कर सकते हो. Reactants याद रखना, reaction याद रखना, बहुत easy है and बहुत important भी है. Now, what is the apparatus, the setup of the apparatus? It's also very simple. Let us move to the apparatus. So you can see on the screen the apparatus setup for laboratory preparation of hydrogen. We have taken a round bottom flask, you can see very clearly on the screen, and the round bottom flask has zinc granules kept inside it, and through a thistle funnel we are inserting, or we are putting the acid, either dilute sulfuric acid or dilute hydrochloric acid. Here there is an oblique which shows that either dilute sulfuric acid or dilute hydrochloric acid is to be put through this thistle funnel. So the reaction is happening here. Dilute sulfuric acid or dilute hydrochloric acid is reacting with the zinc granules, and as a result of the reaction we have just seen hydrogen gas is produced. So that hydrogen gas is now coming out of this delivery tube, and you can see it is collected in this jar. Now here something is very important. How are we collecting it? If you see, this hydrogen gas is collected through inside the water. It is collected inside water, isn't it? and since this gas does not dissolve, means hydrogen gas does not dissolve in water easily, even if it dissolves in trace amounts, so this water will not have the hydrogen dissolved in it. So what will happen, the hydrogen will be collected in this empty region, and therefore we are seeing the hydrogen is over here, and hydrogen is not dissolved in the water because water does not dissolve hydrogen satisfactorily. So हमने क्या देखा कि we are collecting the hydrogen gas by downward displacement of water. इस process को क्या बोलते हैं, downward displacement of water. ये बहुत important term है, it comes in your exam very often. How do we collect the hydrogen gas? What is the name of that process? The term that you have to write is downward displacement of water. क्योंकि water जो है वो downward नीचे चला गया, hydrogen gas is upward. तो hydrogen gas is collected above water, therefore it is known as downward displacement of water. Certain times, in certain laboratory preparation of gases, in different gases, I'm not talking about hydrogen, some another gas, you will see that we don't prepare it by downward displacement of water, because if that gas is highly soluble in water, we can't prepare it by passing it through water. Like for example, ammonia gas. Ammonia gas को जब हम prepare करते हैं, या HCl gas, hydrogen chloride gas को जब prepare करते हैं, we don't prepare it by passing it through water, because hydrogen, HCl gas or ammonia gas, they are highly soluble in water, but hydrogen is not soluble in water, and it's very sparingly soluble in water, means very less in trace amounts that we can, that's negligible. Major part is not soluble. So we are able to get that hydrogen gas above water, and this process is known as downward displacement of water. Why aren't we collecting it over air? That is again an important question. We will see everything, we'll write down. ठीक है, तो मैं ये सारी चीज़ अब लिखाऊंगा. Apparatus clear हो गया बहुत ज़्यादा अच्छे से. यही apparatus based questions कैसे आएंगे? They in exam will never ask you to draw the apparatus. All right? They may give the figure in the question itself, and they can ask you questions related to this. Okay, like what is put through the thistle funnel, and what is kept inside this flask. So they can ask questions. What is the name of the process by which we collect the hydrogen gas, or which gas is present here? They can ask questions like this. Okay. Now observation. Write down, what do you observe when the reaction happens? What do you observe? So we will see bubbles coming out. देखो यहाँ figure में भी दिख रहा है ना, bubbles of hydrogen, taking place, forming over here. So this is known as effervescence. So write down, reaction will gradually start in the form of effervescence, and evolution of hydrogen gas. That's it. Next is collection of the hydrogen gas, जो मैंने अभी बताया. How do we collect it? So write it under a separate heading, collection of hydrogen gas. What is that? Hydrogen gas is collected by the downward displacement of water. बहुत ज़्यादा important है. Underline करो इसको. Downward displacement of water. Now, why do we, collect it inside water, and why not over air? So that we will write reasons. Number one, hydrogen is almost insoluble in water. ये मैंने बताया था थोड़ी देर पहले. And the second reason why it is not collected with air or over air, write down, hydrogen forms an explosive mixture with air and therefore cannot be collected by downward displacement of air. Even if it is lighter than it. Now I will explain this point. Even if hydrogen is lighter than air. Okay, now see. This point, the second point, can be a question itself. They can ask you why hydrogen is not collected by downward displacement of air in spite of hydrogen being lighter than air. देखो हाइड्रोजन एयर से लाइटर है, वो ठीक है, हम जानते हैं हाइड्रोजन इज वन ऑफ द लाइटेस्ट गैस. ओके, सो हाइड्रोजन इफ इट इज लाइटर देन एयर, इट कैन बी कलेक्टेड बाय downward displacement of air, just the way it was collected by downward displacement of water, because water was heavy and hydrogen was lighter than water, so hydrogen got collected over water. जो भारी होगा वो नीचे चला जाएगा, वो downward displaced हो जाएगा, है ना. ये तो नॉर्मल सी बात है. जो whatever is heavier that will be displaced downwards and whichever is lighter that will be displaced upwards, just the way it happened in this part where hydrogen was collected over water because hydrogen is lighter than water. Now in case of air also, air is heavier than hydrogen, so if I collect it over air, it can be, you know, logically if you think, it must be okay, because hydrogen can be collected over air by downward displacement of air, because air is heavy so it should go downward. But then it is not done. The reason is this: it forms an explosive mixture with air and therefore it cannot be collected by downward displacement of air even if hydrogen is lighter than air. So this can come as a question and as a separate question. Okay, very important. Now proceeding further. Now this hydrogen which we are obtaining here, this hydrogen I'm talking about, which we are obtaining in this gas jar finally, is actually not pure hydrogen. It has a lot of impurities present with it. So what are those impurities which are present with this hydrogen? That you have to keep in your mind, and then you have to also remember how do we remove those impurities. So let us move to that topic now. Write down the top heading: Impurities present with hydrogen. So write down the names of all those impurities. Number 1, hydrogen sulfide. Okay, H2S. Number 2, sulfur dioxide, SO2. Number 3, oxides of nitrogen. Oxides of nitrogen like nitric oxide, NO या फिर NO2, oxides of nitrogen. Number 4, phosphine. It is a gas. Phosphine. It is PH3. Phosphine. Number 5, arsine. This is again a gas. ASH3. Number 6, carbon dioxide, CO2, and the last impurity is water vapor, H2O. So we have these 7 types of impurities present with the hydrogen. Now how do we remove these impurities? We will study about that. So the impurities can be removed from hydrogen by passing through. अब कौन सा impurity कैसे हम remove करेंगे, you have to remember. Now by passing through silver nitrate solution you can remove arsine and phosphine. So यहाँ पे अभी मैंने लिखा है arsine and phosphine, दो impurities. Okay, how do you remove arsine and phosphine? By passing it through which solution? Silver nitrate solution. तो हम ये जो hydrogen gas अभी हम prepare किए, that hydrogen gas has to first pass through silver nitrate solution where the arsine and the phosphine will get removed. Now what reaction actually happens? This is arsine, ASH3, isn't it? And silver nitrate solutions हमने pass किया, so it formed this compound Ag3As, AgNO3 and HNO3, and finally this got removed as, you know, it removed in the silver nitrate solution, and we obtain the pure hydrogen gas free from arsine and phosphine. Similarly phosphine से भी हमने यही silver nitrate solution will react and the reaction will happen, and the phosphine and arsine will get removed from the hydrogen gas, so they will not be present anymore with the hydrogen gas. Okay, so now these reactions are not important for your exam point of view. These reactions are not important. What they ask you in your exam is the name of the solution. So they will simply ask you that how will you remove arsine and phosphine, or they can ask you which solution is used to remove arsine and phosphine from hydrogen. You have to simply remember the name of the solution, which is silver nitrate solution. The reaction, this reaction or these reactions are generally not asked in your exams. Okay, now obviously this is school specific thing also, that in certain schools they also ask you, but then in most of the schools they will not ask you the reactions, these reactions. Only the name of the solution is asked. Then the next is lead nitrate solution से pass करेंगे किसको remove करने के लिए? To remove hydrogen sulfide. They can again ask you which solution is used to remove hydrogen sulfide. So this impurity can be removed by passing it through lead nitrate solution. So lead nitrate and hydrogen sulfide will react to form PBS, lead sulfide, and HNO3. So it is again removed from the hydrogen gas. We obtain the hydrogen gas free from hydrogen sulfide. And finally, to remove sulfur dioxide, carbon dioxide and oxides of nitrogen, means this sulfur dioxide, oxides of nitrogen and carbon dioxide, we will pass it through caustic potash यानी potassium hydroxide solution. So ये potassium hydroxide SO2 को भी हटा देगा, carbon dioxide को भी हटा देगा, and NO2 nitrogen dioxide which is actually a oxide of nitrogen, उसको भी remove कर देगा. So finally my gas means hydrogen, my hydrogen gas is free from all the impurities. Only impurity left is water vapor. Water vapor को remove करने के लिए हमें drying agents चाहिए. So there are so many drying agents like calcium chloride, caustic potash, phosphorus pentoxide. We can use these drying agents to remove this water vapor. So to remove the water vapor, drying agents like fused calcium chloride, caustic potash and phosphorus pentoxide are used. So these are the drying agents. Now here there is a very important question associated with this point. Concentrated sulfuric acid is a very good drying agent. What? Concentrated sulfuric acid. We all know its name. But this concentrated sulfuric acid is not used in this purpose to remove this water vapor. Why? A big question is why. Why can't we use concentrated sulfuric acid instead of using these drying agents, fused calcium chloride, caustic potash, phosphorus pentoxide? Because concentrated sulfuric acid is also a drying agent, so why can't we use it? Now the reason is this concentrated sulfuric acid reacts with the hydrogen gas. तो जो हाइड्रोजन हमने प्रोड्यूस किया या प्रिपेयर किया लैब में, उस हाइड्रोजन के साथ ये concentrated sulfuric acid रिएक्ट कर जाएगा, and this completely defeats the purpose of the reaction. We don't want our hydrogen gas to react with the drying agent, right? But this will happen. So we don't react it with, we don't dry this gas, hydrogen gas, with concentrated sulfuric acid. So this is again a very, very important thing. So I'm erasing this portion over here and I'm writing that point. Write down as a note. It is very, very important point. Write down as the first point of the note. Concentrated sulfuric acid is a good drying agent, but it is not used to dry hydrogen, as it reacts with hydrogen thus defeating the purpose of the reaction. Defeating the purpose of the reaction. Now here the reaction you have to study. H2SO4, this if we use as a drying agent, will react with hydrogen H2 and it will form H2O plus SO2. To balance it, put a 2 over here. This reaction you have to remember. But these reactions which I told already, ये वाला reaction या ये reaction या इन सारे reactions को याद करने की जरूरत नहीं है. These reactions are not required, but this one H2SO4 plus hydrogen, you have to study this for your exam point of view. But again I am telling, ये सारे equations generally नहीं पूछे जाते हैं, ये वाले जो मैंने अभी red से जिसको bracket किया हुआ है, लेकिन कुछ schools में फिर भी पूछ देते हैं. So that you have to discuss with your teacher. But in most of the schools these reactions are not asked. अच्छा, point number 2, we will write why did we use granulated zinc. जो मैंने एकदम starting में बताया था कि उसमें impurities present होता है copper के साथ. I told you, no, इस पूरे laboratory preparation में जो हमने granulated zinc का use किया. So write down granulated zinc, या फिर जिसे हम बोल सकते हैं zinc granules, okay, are preferred for laboratory preparation of hydrogen over pure zinc because the impurity present in granulated zinc is copper, which catalyzes the reaction बस इतना ही जानना है आपको. Next thing is, there is a very important thing, that why don't we use nitric acid for the preparation of hydrogen gas. If you remember, we have taken zinc granules and the another acid I told you is either HCl or H2SO4 for the preparation of hydrogen. These are the two acids which we use for the preparation of hydrogen, either H2SO4 or HCl. But why don't we use HNO3? What will happen if I use HNO3? क्या ये reaction नहीं हो सकता? HNO3 का use अगर मैं करूँगा तो zinc nitrate plus hydrogen gas produce. Hydrogen gas क्या produce नहीं होगा? क्योंकि हमें तो hydrogen produce करना है. And ऐसे equation लिखने से तो ये बहुत easily हमें लग रहा है कि hydrogen gas will be produced and we can use nitric acid. No, we can't use nitric acid because nitric acid is a very strong oxidizing agent. This nitric acid will oxidize this hydrogen gas, एंड क्या होगा ना, हमें हाइड्रोजन मिलेगा नहीं, हमें ऑक्सीडाइजेशन हो जाएगा इस हाइड्रोजन का, हमें H2O वाटर वेपर मिल जाएगा. एंड दिस अगेन डिफीट्स द पर्पस ऑफ द रिएक्शन. हमें बनाना था हाइड्रोजन, बन गया वाटर वेपर. क्या तो ये हमारा मकसद नहीं था इस इक्वेशन का. दैट इज समथिंग इंपॉर्टेंट राइट डाउन. So as we were writing, notes में लिख रहे थे ना, heading था note and point number 1, point number 2 हमने लिखा था. Now third point of the same note. Write down. Nitric acid even in its dilute form is not used in the preparation of hydrogen. Is not used in the preparation of hydrogen because nitric acid is a very strong oxidizing agent. It oxidizes the hydrogen gas to water, thus defeating the purpose of the reaction. So हमारा इक्वेशन क्या हो जाएगा, जिंक HNO3 एक्चुअली ये हो जाएगा, रिएक्ट कराऊंगा. सो जिंक नाइट्रेट, वाटर वेपर एंड NO गैस विल बी फॉर्म्ड. यू सी, जो बनाना था हमें हाइड्रोजन गैस, एंड हाइड्रोजन गैस इज नॉट इन द प्रोडक्ट. So this H2O will come up because of oxidation of the hydrogen gas. Now here we will balance it by these numbers 3, 8, 3, 4 and 2. Okay, now again another point. We can make hydrogen gas with very dilute nitric acid. देखो, नाइट्रिक एसिड तो यूज नहीं कर सकते, लेकिन एक्सेप्शन है. वेरी डाइल्यूट नाइट्रिक एसिड विच इज एक्चुअली 1% नाइट्रिक एसिड वी कैन यूज, बट वी विल नॉट यूज जिंक इन दैट केस. हमें कौन सा मेटल लेना है, मैग्नीशियम या मैंगनीज. वेरी वेरी इंपॉर्टेंट क्वेश्चन कैन कम फ्रॉम दिस पॉइंट. मैग्नीशियम एंड मैंगनीज का अगर हम यूज करते हैं इंस्टेड ऑफ जिंक, and if you use very dilute nitric acid, then we can obtain hydrogen gas. So write down magnesium and manganese. These are the two different metals, are the only two metals which give hydrogen with very dilute, this word very must be there, very dilute nitric acid, 1% nitric acid जिसको हम बोलते हैं 1% nitric acid. And if you see the reaction, it is like this: magnesium plus HNO3. Of course this is very dilute HNO3. It gives magnesium nitrate and hydrogen gas. We can even use manganese instead of magnesium. It will happen, it will give the same reaction. So manganese nitrate and hydrogen. So this is important. You have to remember the names of these two metals, magnesium and manganese, and that also very dilute nitric acid, 1% nitric acid. Now, so हमें कौन सा एसिड जनरली हम यूज करते हैं, स्टार्टिंग में ही मैंने बताया था, we will use HCl, dilute HCl, or we can use dilute H2SO4. लेकिन याद रखना dilute H2SO4, concentrated H2SO4 का यूज नहीं करते हैं, because concentrated H2SO4 will also oxidize the hydrogen gas to the same thing will happen to water. Hydrogen gas oxidize कर देगा, because concentrated sulfuric acid is again an oxidizing agent just like nitric acid. So that we will write now. कितना important points associated है, कितनी सारी बातें हम जान रहे हैं, है ना. So concentrated sulfuric acid is not used in the laboratory preparation of hydrogen gas. याद है ना कि स्टार्टिंग में ही जो हमने रिएक्शन लिखा था वहां डाइल्यूट लिखा था, HCl पे भी डाइल्यूट लिखा था. हालांकि HCl हम कॉन्सेंट्रेटेड भी यूज करेंगे तो भी रिएक्शन होगा, लेकिन H2SO4 अगर यूज कर रहे हैं तो इट हैज टू बी डाइल्यूट. वी कांट यूज कॉन्सेंट्रेटेड H2SO4 बिकॉज कॉन्सेंट्रेटेड H2SO4 जो मैंने अभी बताया इज अ स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट. सो क्या लिखा है, कॉन्सेंट्रेटेड सल्फ्यूरिक एसिड is not used in the laboratory preparation of hydrogen gas as it will produce sulfur dioxide gas and water. So zinc plus H2SO4 will give zinc sulfate. The reaction I'm writing, if this is concentrated, zinc sulfate plus SO2 plus H2O, and पूरा रिएक्शन का कबाड़ा हो गया, बिकॉज हम बना रहे थे हाइड्रोजन, बन गया SO2 and H2O. So this defeats the purpose of the reaction. The last topic associated with this topic which we are doing today, laboratory preparation of hydrogen, is the last thing that is required for this topic is test for hydrogen. आपने जो हाइड्रोजन बनाया वो हाइड्रोजन ही है कि कोई और चीज आपने बना दिया. हाउ डू वी टेस्ट दैट द गैस विच यू हैव मेड इज हाइड्रोजन? नंबर वन, द टेस्ट इज हाइड्रोजन इज अ कंबस्टिबल गैस. इट कैचेस फायर वेरी इजीली. ओके, सो दिस इज वन ऑफ द टेस्ट्स. हाइड्रोजन इज कंबस्टिबल मतलब खुद जल जाता है, इन्फ्लेमेबल गैस, बट इट डज नॉट सपोर्ट कंबस्टन. सपोर्ट कंबस्टन नहीं करता है लाइक ऑक्सीजन. ऑक्सीजन supports combustion. Oxygen is present for burning, for combustion, but it itself does not burn. So oxygen is a supporter of combustion. Hydrogen is not a supporter of combustion, but it burns itself. It is a combustible gas in itself. This is the first test. The second test is pure hydrogen. When I talk about pure hydrogen, then it burns silently in air. चुपचाप, मतलब कोई साउंड, पॉप साउंड वगैरह नहीं होता है. जनरली वी हैव अ नोशन दैट हाइड्रोजन बर्न्स विद अ पॉप साउंड, बट दैट इज नॉट विद प्योर हाइड्रोजन. प्योर हाइड्रोजन बर्न्स साइलेंटली इन एयर. यू हैव टू कीप दिस इन योर माइंड. प्योर हाइड्रोजन बर्न्स साइलेंटली इन एयर और ऑक्सीजन. And the color of the flame is again important, with a pale blue flame. Pale blue flame forming water. Hydrogen plus oxygen. This is the pure hydrogen I'm talking about. When this pure hydrogen burns with oxygen, it forms water. And the flame is pale blue flame. Now, hydrogen premixed with air or oxygen burns with a pop sound. So clear? So if I take pure hydrogen, it will burn silently. But if I take hydrogen which is premixed with air, पहले से कुछ oxygen या air उसमें मिला हुआ है, this hydrogen if I try to burn, it will burn with a pop sound. So you have to remember these 2 points. Here we complete this topic, laboratory preparation of hydrogen. this chapter has more topics, important topics to do, which we will cover in the coming lectures. However, in this lecture we have covered a lot of important questions. You will find that hydrogen chapter का major part of questions come from the topic which we have done today. आज का जो lecture अभी किया ना, इसको बहुत seriously करना. इसमें बहुत सारे topics हमने, बहुत सारे important points हमने cover up किया है. कम से कम इसमें से तो 15 marks के questions आज ही हमने cover up किया है. 15 marks के questions minimum. So go through all the points carefully and do your preparation properly. Happy learning. God bless you.